All right, so let's talk about some of these from that assignment on yesterday. Right? So on 35 and on 36, there's three things that you need on this. Three. You need the E naught value. You need to tell me if it's spontaneous or not spontaneous. And then the balance reaction if it's not already balanced. And some of them are, okay? So like if you look on 35A, that's already balanced. You don't need to rebalance it, okay? But if it's not balanced, then you need to. Like let's say, for example, you get into like 36, especially 36. Neither one of those on 36 are balanced. And that's when you got to be able to go through and do the half reactions. So on 36, this is what you're going to have to be able to do on the quiz tomorrow, okay? The half reactions in oxidation, reduction, use waters to balance out your oxygens, use hydroniums to balance out your hydroniums, use your electrons to make everything balance out. So what you should see on 35 and 36, on each one of them, one is spontaneous, one is not spontaneous, okay? So do not make me sort through random little bits of information that you want to write down somewhere hidden within this problem. So clearly indicate if it's spontaneous or not. Clearly show me the E naught value, whether it's positive or negative, I don't care. Show me that E naught value. And then, especially on 36, show me the balanced equations. So on 36, A and B, on both of those, if you did that right, you should end up with 8 waters. Okay, so on the balanced equations on 36, A and B, both of them, you should have 8 waters as products. Okay, just saying. Now, on 47, you have to understand like what the code is asking for on 47. It says, rank an order of increasing strength as oxidizing agents. Okay? So you want to rank them in increasing strength as oxidizing agents. So you have to start with the vocabulary. Okay? What does an oxidizing agent do? It reduces. Okay? So an oxidizing agent reduces. Okay? So what's the next logical step? What does it mean when something reduces? What does it do? Gains electrons, right? So what you're looking for in increasing strength, so you're going to start with one that's least likely to gain an electron and end up with one that's most likely to gain an electron. Okay? That's how this is going to rank out. So let me give you a hint. Your first element on this list on 47 should be the potassium ion. Okay? And again, you have to look at what you have, right? You don't have elemental potassium, you have K+. Now, let me ask you this. Which one of those two do you think would be most likely to take in an electron? Potassium ion or the element form of potassium?
Potassium ion.
Why?
Because why would potassium going to go negative?
Yeah, okay? That would just be weird. Potassium only has one valence electron, okay? And then you're going to tell it, no, we're just going to gain another one. It doesn't make any sense at all because that's going to be even more stable. So potassium ion at least has the capacity to take in an electron. The potassium, not so much. Now, riddle me this. Which one of those two, Cl minus or Cl, would be the better reducing agent? So if it's a reducing agent, what's it going to do? Which means it's going to do what? Lose an electron. So do you think the elemental chlorine, okay, so if you look at the atom of chlorine, not the ion, the atom of chlorine, How many valence electrons does that have?
7.
7. So you can visualize this like if you get 8 electrons, or it's a game, it's a board game, something like that. If you can get to 8, that's like the magic number. You're the winner, okay? Well, this has 7, right? So it's really, really close to having 7. It's like, dude, I just need one more. So that means if you're already at 7, you probably don't want to lose an electron. Now, Cl1 minus, you have gained it. Like if you have gained an excess electron, that at least has the capacity to do that, but not much of one, mainly because it has the 8 electrons. Now, which one of these two, Cl minus or the elemental chlorine, would be most likely to gain an electron? Why?
Because I almost get one more than the
Right. So chlorine would really, really, really like to gain an electron because then it can get to 8 electrons. So if chlorine really, really, really wants to gain an electron, right? Gain an electron, that's going to be reduced. So this would be a great oxidizing agent, okay? Because it really, really, really wants to take in electrons because then it wants to turn into that stable arrangement of Cl minus. Okay. So 47, that list is going to start with the potassium ion. On 49, you should have 2 no's and 2 yeses. Okay, not in any particular order, but you should have 2 no's and 2 yeses. When you get to 50, and on 50, make sure you only did A, B, and D. On 50, you should have 2 no's and a yes. Now, when you get to 51,
or 51 is confusing, man.
well, that's what I want to talk about. Chill out. We'll get there. So let's start with 51A, which is the strongest oxidizing agent. Okay, so again, think this through. If it's a strong oxidizing agent, what does it want to do? Be reduced, so it wants to gain an electron. Okay, so let's look at this list. So you have Na plus, you have Cl minus, you have Ag plus, elemental silver, Zn2 plus, Zn, and lead. Okay, that's what you have available to you. And because of the fact that you're asked the strongest oxidizing agent, you're looking for one of these that's most likely to gain an electron. So imagine this is like a police lineup, and we're sitting here going, okay, here's our possible suspects. Which one most likely stole an electron? Okay? Now, some of these we can just eliminate right away. Would Cl minus want to gain another electron?
No.
No, because what would you end up being if it did?
Minus extra.
Yeah, you'd have Cl2 minus. You ever seen Cl2 minus? No, you know why?
It probably doesn't.
Doesn't exist. Could sodium gain an electron?
Yeah, I could try.
Could.
Possible.
Could. It's a possibility, not likely, but it could. Because then you're just going to make elemental sodium, and you all saw what happened when sodium itself is really reactive. Possibly, not likely. Now, what about elemental silver?
No. Ooh.
Then you'd have Ag1 minus.
Never heard of it.
No. Never see Ag1 minus. You know why? Doesn't exist. It's not stable. All right, so we can eliminate that one. Same thing with lead 1 minus. You never see that. You never see zinc 1 minus. Okay? So none of those are going to be, none of the elemental forms of these particular ones, because they're metals, are going to be likely to gain electrons in the elemental form. Now, let's talk about Ag plus versus Zn2 plus. Those are possibilities. Okay? Those are these possibilities. So, again, you have to be able to use the power of the table. Okay? if you're trying to make this happen, and you're trying to find an oxidizing agent, keeping in mind that this thing is going to be reduced, are you going to look for reactants on that table, or are you going to look for products on that table? I'm going to look for reactants. So right away, you can't even find Na plus on there as a reactant. Okay? You can, but it's way, way down at the bottom. So Cl minus, that's not going to happen. So then you're basically left with Ag plus and Zn. So are you going to look for the one that's higher up on the periodic table or the one that's lower down? The one that's higher. So what do you have as an answer then for 51A?
So, what?
Silver or the silver ion?
Silver plus.
Yes. Because there's a huge difference between silver and the silver ion. Okay, vastly different. They are not the same thing. Isaac Bruce.
Mind covering what the difference exactly is?
Between Ag plus and Ag?
Yeah.
Okay. So here's the difference. If you have the elemental form of this, your Ag. So what's the atomic number of silver? Look behind you, Olivia. Find silver. What's the atomic number of silver?
Oh, it's, oh, you know.
47.
47?
You can read that.
Okay. So if it's a neutral atom, you have 47 St. Bernards in the nucleus, and you have 47 chihuahuas running around. The number of negative charges balance out the number of positive charges. Okay? If you have Ag plus, you still have the 47 St. Bernards. You still have the 47 protons. Because if you change that, you change the element. Okay? So anything that has 47 protons is going to be silver. So what the plus indicates is that I have one more St. Bernard than I have Chihuahua. So this means that I have 46 Chihuahuas surrounding 47 St. Bernards. So I have one extra positive charge. So that's why when you look on that chart, on that reduction chart, you see Ag plus one electron turning into silver. And that's a pretty big positive number. So what that means is that this really wants to go in this direction. What you don't see anywhere on that chart is Ag plus one electron turning into Ag1 minus. This is not on the chart because the silver atom is not going to gain an electron to turn into a negatively charged ion. But an Ag plus ion will gain an electron to turn back into silver. See the difference between the two?
Yeah.
Okay, fantastic. On 51B, that should be an element and a metal.
Wait, that's the one I don't understand.
Okay. All right.
I miss
I just wanted to see what AP Chem was doing today.
Re-dox tables and we'll take so.
It's like you taught me that before.
Shut up.
Redox?
Yeah.
Yeah, I did. Not redox tables. Like we didn't do voltaic cells, but you should know how to set up a redox reaction
me
and
the
figure out the
foundation.
electron.
You gave me the foundation.
That's the goal of Chem 2 is to give you the
Thank
foundation.
you so much.
That's what we're about to start too next week.
Okay. All
We're
right.
doing acid bases and ice tables right now.
Ooh, nice. Acid tables on ice. That's nice. Okay. So you look on 51B. Which is the strongest reducing agent? What are you trying to find?
What gets oxidized?
The one that's most easily oxidized, right? So you're trying to find the one that's going to do what? Lose electrons. Okay? So let's look at the possibilities. What about Na plus? Do you think Na plus is going to lose another electron? Not going to happen. Why?
Na2 plus is a no.
Na2 plus is no-no. Mainly because how many valence chihuahuas does sodium have? One. It already lost the one, and now it's down to that stable electron configuration. So you're never going to see Na2 plus. Not going to happen. Okay, so we can eliminate that one. Right?
Yeah.
Yeah. Okay. Now, you've got Cl minus. Kind of the opposite side of that coin. Is Cl minus going to lose an electron and turn into Cl plus 1 electron?
Unlikely.
Not likely. Why?
It already has an octet.
Why did it gain that electron to begin with?
So it's not else.
Because it had, and it wants,
Oh, so it's satisfied.
well, it's cool. Okay? It's not cool, right? Okay? Now, you got Ag plus. You shake your head no, why? Yeah, you never heard of Ag2 plus. Ag plus all day long. Ag2 plus, not so much. Okay? So you got that. Then you run into Zn2 plus.
No,
You're going to make Zn3 plus?
not a chance.
Not a chance. Now you're left with zinc and lead. Now let me give you a hint. Okay? If you're trying to find a reducing agent, which means it wants to be oxidized, are you going to look on the reduction table? Are you going to look? God, you're psychic. Okay?
How'd you do that?
Are you going to look for products? Or are you going to look for reactants? Products. Top product,
No, bottom.
bottom product.
I got that one.
That's emphatic. Okay, so which of those is the lowest bottom product? Well,
I wouldn't mind. It's not lead. Oh, so we're looking at
So it's zinc then. Zinc.
I do
Yeah.
it.
Zinc and no.
mark of.
Zora. Zelda.
There you go. Now,
It didn't work on Zoid.
good. Now, let's talk about C. Which species can be oxidized by sulfate in an acidic environment? So you have these sulfate ions floating around. Now you're in an acidic environment. So what does that else mean that you have?
Plus.
You got a bunch of hydronium ions, a bunch of protons floating around. Okay? So you have to again understand the code. It says which of these can be oxidized. So in other words, you're going to try and find the ones that sulfate can go up to them and go, excuse me, hello, I'm collecting chihuahuas for the homeless, can you spare any? Okay? So you're trying to find the elements or ions that are willing to give up the chihuahuas to help the homeless. Okay? That's what you're trying to do. Now, sulfate comes up, knocks on the door of Na+. Goes, hey, spare Chihuahua. Help her brother. You shake your head no. Why?
Na2 plus.
Yeah, you're not going to make Na2+. Na+ is going to go, dude, I already gave the one Chihuahua away. I'm happy. I gave to the office. Leave me alone. Okay? Na+, not going to happen. But again, you're trying to find things, elements, ions, whatever, that are willing to give up electrons. Right? So let's start with that idea. Na plus is not going to give up an electron. Cl minus, not going to give up an electron. Okay? So, but here's the other mathematical way to look at this. If you look on that big complex one chart that I gave you yesterday that has all, even like the solutions on it, okay, you can find the E0 value for the reduction of sulfate. Okay? So this has to go in this direction. So the sulfate is going to act to take the electron. This thing is going to go in this direction, right? So you have to find something that gets flipped, but yet you want the E0 value to be a positive or negative value. Positive. So what's the E0 value for sulfate? Exactly 0.2?
Yeah.
Okay, 0.200. Okay, it wants to go in that direction. It isn't the best, but it's not bad. It's 0.2, right? Okay, slightly above 0. So this is important. This is going to stay in this direction. Okay, this is going to stay in this direction. This is not going to become negative. Now, mathematically, if for those of you that are math nerds, 0.2 volts plus something has to equal a value greater than or equal to 0. If you're a math nerd. Okay? If you're a math nerd. Because your E naught value has to be a positive number. But if it's going to get oxidized, what's going to happen to the numeric value of any E naught value that is on that chart? It's going to get flipped. Okay? So basically, like for example, I couldn't have something that had a negative E naught value of negative 2.20. Couldn't happen after I flipped it. Because then I'd get a negative E naught value, which is, it wouldn't be spontaneous. So on 51C, you should have 2 elemental forms of metals. There's 2 answers on 51C. Okay? Elemental forms of metals. Okay? Cool with that. One of them is really dense.
Ooh, people use it in the back.
Okay. Now, on D, which species can be reduced by aluminum? Okay? So, here's what's going to happen. Here, you have to switch your mindset. On 51D, which of these can be reduced by aluminum? So basically, what you're trying to find are elements or ions that can take electrons away from aluminum. Okay? So aluminum, again, just think about this. Aluminum is not going to gain electrons and turn into Al1 minus. You ever see Al1 minus? No. Al becomes a cation of Al3 plus. It loses its 3 valence electrons. Okay? So basically what you're trying to find, which elements can come up to aluminum and go, excuse me, can you spare some chihuahuas? You're trying to find the elements or ions that can take the chihuahuas from the aluminum. Again, eliminate these. Is Cl minus going to go up to aluminum and take a chihuahua? No, you know that is not going to happen. Okay, it is not going to happen. You are not going to make Cl2 minus. So to a certain extent, this is a process of elimination. Okay, what's possibilities? So 51D should have 2 answers as well. And they should both be cation ions.
Yes.
When we're talking about, again, 49, we're talking about iron 3 plus. How do we know, like for its EV value, if it's going from like iron 3 to iron or iron 3 to iron 2 plus, or iron 3 plus to iron 2 plus?
So on 49, so generally what happens if it's Fe3 plus, it'll go to Fe2 plus, and then it'll go from Fe2 plus to elemental iron. So it'll generally go in stages. So Fe3 plus, like we're on a stair step, we'll go from Fe3 plus to Fe2 plus, and then from Fe2 plus to iron. Okay. Sometimes you can make the door swing all the ways, but generally it goes in stages. Okay. Anything else? Make sure on 51 that you have given me a justification for it. And just don't say it's going to happen. That is not a justification. You can talk about E naught values, positive, negatives, things like that. You can say, oh, it's here on the periodic table or on the reduction table. Just don't say, oh, it's going to happen because Mr. Burkamp said it will. That's not a valid explanation. Okay, we're good. Once, twice, sold. Stop you on the camera.
You want it stapled or not?